This Calc 1 lecture is about the average value of a function. The passage that you see here on this page comes from your textbook, section 5.3, and I think it provides an excellent explanation of the average value of a function, the concept of that. So I'm going to ask you to pause the video and either read from your screen or pull out your notes and read this particular page. Okay, a couple things that we need to point out here. Average. You all know that to find an average, you add up a bunch of things and you divide by how many there are. For example, if I ask you to find the average of your first 4 tests in calculus so far, you add all 4 of those up. You divide by 4, and that gives you your test average. Next, this passage provides you an example discussing the average temperature in a town over the course of a day. And the passage describes where if the temperature never changed all day, then that would be the average temperature. However, we know that's not, or is very, very rarely the case of a temperature in a town. It goes up and down. It varies during the day. So what would it mean to find the actual average temperature? And this example provided talks about this in terms of area. And I absolutely love their analogy to water in a tank. I can picture a tank or a swimming pool when people have jumped in and the water is sloshing up and it's not flat, versus when no one has been in the pool, there's no wind, no rain, nothing to disturb the top of the water, and you've got the same height of water all the way across the pool. Now, I'm envisioning a pool that's like just a rectangle with no shallow or deep end, that it's the same depth all the way across. And so when I look at this picture, I imagine this is what the top of the water of the pool looks like when people are splashing around, and this is what it looks like when it is very still. And this passage describes to us how to find the average of this function by thinking about all the water becoming still at the top. Now, let's put some numbers in here. Let's suppose that A is 9 and B is 8. So that means that we have 8 units of distance here. To find the average, we would need to take this entire area here, all of that, and divide it by 8 in this particular instance. And that would give us the average value of the function. In other words, if we're talking about areas, we would have units per square units per measure of x. So we are going to find the average value of any kind of function that we want using this idea, and we know that to find the area under a curve, we use an integral. So let's look at the definition here on this next page. If a function is integrable, able to be integrated, on some interval from a to b, then its average value on that interval a to b, also called its mean, is. This stands for average value right here. This is what I am dividing by. Remember last time we said x went from A to B. And so if this is my x-axis right here, then I subtracted those. B minus A was 8. B minus A is 8, and I was dividing by 8. Dividing by 8 is the same as multiplying by 1 over 8. So I am taking this 1/8 and I am multiplying it by my area under my curve from that same interval from A to B. So this is the first problem that we are looking at. It's an example in your textbook, and it says to find the average value of f of x, which equals rad 4 minus x squared, which is the top half of a semicircle. Well, top half of a circle. And we are looking at the interval from -2 to 2. So let's look up here at our formula. We are supposed to figure out how far away it is from B to A. So my average value will be equal to 1 over 2 minus -2. Well, look, we can count 1, 2, 3, 4 units away. So yes, I'm going to be dividing by 4 or multiplying by 1/4. I am taking the integral from -2 to 2. And my function is the square root of 4 minus x squared. Don't forget your variable of integration, which would be dx. Now we have a little bit of a problem here, and that is that we don't know how to integrate this. Because if you try to do u sub on here, when you anticipate the derivative of 4 minus x squared, you get -2x. There is no x anywhere else in that problem for you to be able to do integration by substitution. So you can't. So in this particular problem, you don't know yet, you'll learn in Calc 2, how to integrate. So all that you would be able to do in this particular problem, calculus-wise, is to set up that integral. So let's go back and look at this problem from a geometry point of view. We know how to find the area of a circle. It would be pi r squared, but I don't have a circle. I've got a semicircle, so it would only be half of that. We can see from our picture that our radius is 2. So I would have 1/2 pi times 2 squared, or 4, which is 2 pi. Remember that you need to divide this by the number of units to get the average, because all I have is the area. So my average value for this function would be 2 pi, there's my area, which if I knew how to integrate, I could find this way with this integral, divided by b minus a is 4. So the average value is 1/2 pi, or pi over 2, which I'll just tell you how many. That's approximately 1.57 square units per unit of x. Now, you do not need to write your answer this way, but I want you to understand what you're actually finding. You are finding that, look at the orange square here, you are finding that per unit of x, so here's 1 unit of x, that there is 1.75 square units of area per unit of x. All right, let's do one where we can actually find, using calculus instead of geometry, our average value. You are asked here to graph this function and to find its average value. Guys, I graphed it for you right here, but let's talk about you actually graphing this thing. You understand that it is a parabola, so let's find the x-intercepts. We know that to find x-intercepts, I let y equal 0. So I would have 0 equals t squared minus t. So that would be t times t minus 1. Or t would be 0 and t would be 1. So I've got these points right here. Second, let's try to find the vertex of this parabola. Do you remember that that's negative b over 2a? And b is negative 1, and a is 1. Here's b right here, the coefficient in front of the t. Here's a right here, the coefficient in front of the t squared. So my vertex would be the opposite of negative 1 over 2 times 1, or it would be 1/2. This is the x-coordinate of my vertex. When I plug in 1/2 into my function to find the y-coordinate of my vertex, I get out a negative 1/4. So my vertex here is, if this is a half and this is a fourth, is right down here at 1/2 comma negative 1/4. Now I am asked to find the average value from negative 2 to 1. So in other words, we're looking at this area and this area. One other thing I want to do, I want to actually find that point right there. So I am going to plug in negative 2. And when I do that, I will get out 4 minus a negative 2, or a 6. So I'm probably not quite high enough up here yet. All right. So here is the graph, and again, I'm trying to find the average value of this function, f of x. Oh, we would need to change that to t. F of t equals t squared minus t from negative 2 to 1. All right, so let's go and do the average value work. Let's get rid of my graphing work and find the average value. So the average value of my function is, all right, I'm supposed to divide by 1, 2, 3. Remember, this is b, this is a, so it would be 1 minus a negative 2. That's 3 units. I am taking my integral from negative 2 to 1 of t squared minus t dt. So my average value will be, when I integrate, t cubed over 3 minus t squared over 2 from negative 2 to 1. So that's 1/3. When I plug in a 1 for each t, I get out 1/3 minus 1/2. When I plug in a negative 2 for each t, you guys be careful, because let me show you something that you guys mess up on. So negative 2 cubed over 3 minus negative 2 squared over 2. Big parentheses, can't see the big parentheses, big green parentheses. So let's move this over here so you can see better. 1/3. We have, again, when I plug in my purple, 1/3 minus 1/2 minus, now let's plug in my, I have -2 cubed over 3 minus -2 squared over 2, close parentheses, close bracket. Now, the reason it's so important to put the -2's in parentheses here is because you all tend not to square and cube things correctly with negatives on them. So I would have -1/3. This is a -1/6. This gives me -8/3 minus +4/2. So I'm going to move up here and write on my graph. I'll get a 1/3. I have a -1/6. This works out to be a 28/6. So I come up with a 3/2. Now, think about what this means geometrically. I'm trying to help you connect your algebra to your geometry. The average value of this function means that for every, let me find a totally different color, let's use red, that between -2 and 1, the average value of this function is 3/2 or 1/2. So 1/2 square units per unit of x. Okay, that ends our lecture for the average value of a function. Please make sure you practice your homework, and if you have any questions, let me know.